Welcome to Future Talk. On today's program, we're going to talk about the future of energy and whether it's possible to dispense with fossil fuels altogether and get all of our energy from clean sources such as wind, water, and solar power. My guest says that it is possible. He is Mark Z. Jacobson, Director of the Atmosphere Energy Program at Stanford University and a leading researcher in atmospheric science. Professor Jacobson studies the physical and chemical processes involved in air pollution and looks for ways to integrate clean and renewable energy into the power supply. His computer models of the atmosphere have been used by about 1,000 researchers in the field. His work has served as the scientific basis for proposed climate legislation. He served on an advisory committee to the U.S. Secretary of Energy and has testified several times before the U.S. Congress. Mark, welcome to the program. Good to have you here today.
Thank you very much, Marty. It's good to be here.
Now let's talk a little bit about air pollution. Just how serious a problem is this, and how urgent is it that we start cutting back on fossil fuels?
Yeah, we look at air pollution and climate problems and energy security. And air pollution is one of the 5 leading causes of death worldwide, with 2.5 to 4 million people perishing each year prematurely from air pollution and the complications arising from it. And this is not only devastating to families, and in fact, in developing countries, about 20% of the air pollution mortalities are children under the age of 5 years old. But it costs society on the order of 3 to 7% of the GDP, or the gross domestic product, of individual countries. In the United States, there's still 50 to 100,000 people who die prematurely each year from air pollution. In California, it's about 16,000 per year. And in New York State, for example, it's about 4,000 per year.
It sounds like quite a bit. We have a couple of slides that show air pollution. Can we see the first slide, please? Okay, so this is someplace in Russia, Norilsk, Russia. Is that an average day for this town, or is this the worst day ever? I mean, what's the context for this?
Yeah, if we look in North America and Europe, air pollution has gotten better, but in most of the world, including in Asia, in Russia, Southeast Asia in particular, and lots of parts of Africa, you have really serious air pollution problems. So this would be very typical, but not always. You don't always have air pollution this bad. But just to give you an example, in China, between 800,000 and 1 million people die every year of air pollution. You can have 2 or 3 weeks where the visibility is very bad.
Is air pollution a contributing factor to the deaths or the primary factor in the deaths?
It's both. Well, people die from cardiovascular disease, complications from asthma, respiratory illness, and in the case of children, it's like their immune system is weakened, so they're more likely to die of pneumonia. So if you have a heart attack in polluted air, you're more likely to die of that heart attack than if you have a heart attack in clean air.
We have another slide showing air pollution in India. Can we see that one?
Yeah. So
okay. So what are they burning there? Are they burning coal or gas?
Well, this is most likely a chemical factory where they're producing some products, and they're burning chemicals, and so that's causing the coloration of the air.
Now, will they say, well, we know this is a problem, but we can't afford to clean it up economically? We don't have enough money to generate cleaner energy.
Yeah, that's the excuse many times. But the fact is that the air pollution is causing lots of costs in terms of to the society that are being borne by the entire society, and nobody's paying for those costs except for the families. And even in the U.S., air pollution illness, as I said, it costs 3 to 7% of the GDP, and that's in terms of hospitalization, lost work days, lost school days. We pay higher insurance rates, we pay higher taxes as a result of air pollution mortality, and also what's called morbidity or illness related to air pollution.
Well, let's talk about some of the sources of clean energy. So we're going to talk about sunlight a bit. Is that able to be used on a large scale? Doesn't it take a lot of land area to gather enough sunlight to generate significant amounts of solar electricity?
Not really. So I can give some examples, but solar and wind in particular are 2 ubiquitous energy sources, clean natural energy sources, that are the only 2 energy sources really that you can actually power the entire world many times over with. So for example, there's enough solar energy over land and high solar locations worldwide to power the entire world's energy infrastructure for all purposes about 30 times over.
And I think we have a slide of that. Can we see that slide? Okay, so.
Yeah, this shows the solar resource of the world, and the red indicates where you have higher solar and the blue is lower solar radiation.
It looks like there's more solar over the ocean. Is that true?
Oh yeah, you get a lot of solar over the oceans. It all depends. This is the downward amount of solar radiation. So if you have, sometimes you have areas where you have a lot of reflection of light. So you get, even though you have the same amount getting to the surface, not all of it gets absorbed by the surface.
Now we have a slide that shows some of the uses of solar energy, what a solar array might look like. Can we see that slide?
Yeah. Well, this
okay, I think that's the wrong slide. I think we want to go back and yeah, you almost had that one.
Well, the solar slide, it's going to show.
That's the one. Okay.
Yeah, it's showing two types of solar. One is what's called concentrated solar power, which is the left slide top, and that's where you focus light off of mirrors onto a central tower receiver to heat a fluid, such as what's called a molten nitrate salt. And that salt, it's really nice because it's hot now, and you can store it at night and then you can use it at night to run it by water, to evaporate the water, to run a steam turbine to generate electricity. So the nice thing is then you can actually generate electricity at night with solar power this way. So some of these towers have been put up around the world, mostly in Spain and in California, and they've actually been used to generate electricity 24 hours a day. So this is a way to get rid of the old problem of where solar can only be used during the day when the sun is shining. In fact, it can be used 24 hours a day with this type of technology. The more common type of technology, which is on the right side of that previous photograph, is solar photovoltaics, is where you generate electricity with photovoltaics. They're either in power plants or on your rooftop. So it's rooftop solar.
Is there any place in the United States where solar power is actually pumped into the main power grid?
Oh yeah, in almost most states, you have some solar power that goes into the grid either from rooftops or from power plants. In the Southwest U.S., where you have the greatest solar resources, you have the greatest abundance of solar that's already installed. California has a huge amount of solar already installed, both on rooftops and in power plants that's already generating lots of electricity for the state.
Now, is this electricity, how does it compare economically with electricity generated by oil or gas? Would people have to pay more for this kind of energy?
Well, this is an interesting question. So wind energy is actually, if you're in a reasonably fast wind location, is the least expensive form of all electricity, whereas solar is more expensive right now than your average electricity, but the price is coming down. So just to give you an idea of why wind is so inexpensive, if you take the 5 states in the U.S. that have the highest fraction of their electricity from wind, which are Iowa, South Dakota, North Dakota, Minnesota, and Wyoming. In fact, Iowa and South Dakota generated 25% of all their electricity from wind last year. The price of electricity in those states between 2003 and 2011 went up only 2 cents per kilowatt hour. All the other states, the electricity price went up 3.6 cents a kilowatt hour. In Hawaii, it went up 17 cents a kilowatt hour in that same period.
Is that because the price of gas fluctuates?
It's because the price of fossil fuels continuously goes up because you have to mine them, transport them, and refine them. And so there's all these costs that go into fossil fuel, the fuel price. Whereas solar and wind, there's zero fuel cost. All the cost is in the capital cost, which is installing the turbines or the solar panels. So once you've installed them, you have a constant price after that. Whereas the other fuels, once you've installed them, the other fuels have a lower, what's called capital price cost, but their fuel cost is higher. So they gradually go up over time. So what we expect is eventually all the renewable energy sources, the prices are going to be less than the fossil fuel sources. It's just a matter of when. And right now, wind is actually in fast wind locations and modest wind locations is less expensive than natural gas or coal, except for old coal, which is grandfathered in under the Clean Air Act amendments, where they don't have to put in pollution regulation.
Well, let's talk about wind a little bit. I think we have a slide showing the pattern of wind. Can we see that slide?